Hi everyone, I am Setu. This is second and final session of Bitcoin PR Basics review. Hope this helps you get started with Bitcoin PR review. Raj, as usual, please do your magic. Over to you.
Hey, thanks for joining, guys. So this episode, last time we saw like how to check out a PR and how to compile and run all those tests. And this time we are going to give you a basic tour around the Bitcoin core code base. So if you haven't been or seen the Bitcoin internals before, or if you are new to open source in general, the Bitcoin core code base is like quite massive and quite exhaustive. So our intention is to ease you through the world of Bitcoin source code and explain what are the things that are available and what are the things that you can scour on. So, with that, let's just jump onto it and I'll share my screen. And you can see this is the Bitcoin Core GitHub repo. So this is where the Bitcoin Core code base lies. We have like checked it out last time and compiled the entire thing. This time we will basically check out what are the different components, what are the folders, what are the content of it. And before jumping into any code, I just want to show you guys the English version of it, that is the docs. So Bitcoin has a lot of documentation in the docs folder, and all these docs are pretty extensive. A lot of work has been done in making the docs explainable and easy to read. And you can take your time to read through various documentations. Here, I will just focus on the basic stuffs that you might want to be interested in. So there are like lot of like design man policy release notes, and these are like manuals. These are like some design docs that are like explaining some internal design considerations. Those are pretty advanced. You might want to like scour them at your own time. And so at the start, I want to start with the Bitcoin conf. So bitcoin.conf. So every time you start a Bitcoin node or the Bitcoin D process, it will automatically create, either it will try to read a bitcoin.conf file if you have it. If you don't, then it will automatically create a bitcoin.conf with default configuration for you. And this document basically describes how the syntax of the bitcoin.conf file is. So for example, if you can specify different segments of the configuration file, for example, under this main banner, if you can, if you, whatever the configuration you values and parameters you put, those will be like the mainnet parameters. And if you run Bitcoin D in mainnet mode, only those configuration will get activated. Same for test, signet, and reg test. So each configuration file can be separated via like different segments for like different network configuration. And the configuration file directory is like for Windows, Linux, and home Mac OS. These are the default data directory, given that you don't change it while running Bitcoin D. On Linux, you will have it at your home.bitcoin. In Mac, this is the path, and in Windows, this will be the path. And this is the entire data directory of Bitcoin. So not only just the bitcoin.conf file, but all the different kind of datas of the Bitcoin will be residing on this folder. We'll talk about this folder a bit on later on. So this is bitcoin.conf. After that, you will have a lot of build documentation. So depending on your operating system where you want to build it, you will have to follow different instructions and different dependencies, right? So these documents basically outlines like for which operating system what are the instruction you need to follow. For example, if you're a Unix or Linux user, these are the configuration these are the commands. Last time we already did this part. We didn't do the install, but we did compile the source code in Linux. So we already played this command over there. And then there are different configuration variables at the compilation configuration. So this configure is not bitcoin.conf configure, it's the configuration for compilation. So how do you want to compile it? What are the components you want to add while compiling and all these kind of things. So this has like a pretty extensive things depending on different stuffs. If you wanna do ZMQ, if you wanna do GUI, if you wanna do QR code, you need to install like different dependencies. So follow the build documentation depending on your operating systems, and you will find all the information over there. And then we have dependencies.md. Dependencies is basically list out all the dependencies that you need in your system to compile Bitcoin code. So you need autoconf, automake, clang, gcc, python, system tap, and all these things are basic stuffs. These are the optional dependencies if you want to do GUI, if you want to do fancy stuffs with networking, wallet, and all. So you need these dependencies at the start also. So in the build doc itself, you will have like the dependency installation command. So you don't have to worry about how to install autoconf. If you follow the build doc, you will already have it installed, hopefully. So then the one of the important part is developer notes. In developer notes, basically this is extensive documentation for all the future contributors or potential contributors on how to write code in Bitcoin code. Not like how to write code, but what are the conventions you need to follow, how you should like format the comments, how you should like name the variables, and how you should like that. There are the different tips and tricks that you can use, how to use the debug log, how to do different kind of debug situations, and valgrind and performance profiling and all these kind of things. So basically, if you are going to be a serious developer for Bitcoin Core, you would want to go through this documentation very carefully, and you want to like adhere to the principles, as well as you will get a lot of tips and tricks on how to do that. Along the same line, there is another doc called productivity.md. So productivity note is basically once you are like working daily on Bitcoin Core, um, it takes a lot of time to compile and do various things. So this document is basically some tips and tricks on how to like fast up your development process. So every time you make a change, you need to recompile the code base, then run the test. And this document shows you like how to do that in a quickest way possible. So these are basically like power tools you want to have in your hand, and while working on this thing. So one of the most important is cache compilation. So you don't want to compile the entire code every time you change a line. So what cache compilation does is like if you change one single line, it will just only recompile that particular module and not compile the other part. So you save a lot of time by not compiling the redundant thing that you didn't change. So that's very useful. Um, and then it has a lot of like conceptual documentation. For one thing, that is like descriptors. So if you don't know about output descriptors are things that allows you to very quickly describe complex Bitcoin output in a string format. So for example, this thing is a multisig of two of three public keys, right? And instead of like writing the entire, it's a two of two multisig, instead of like writing the entire multisig script, you can write this string. And any software that can understand descriptors, including Bitcoin Core, there are other softwares like BDK and other things where you can create a wallet with a descriptor. You can like write your policy in a descriptor string, and the software will like understand how to handle those kind of scripts. So you don't have to go and engineer the Bitcoin scripts inside the software yourself. So this is a very handy thing, and this is getting adopted in the space very quickly. And so this document is the most extensive document on descriptors that you will find out there in the literature. So the doc folder also like contains various kind of like concepts and notes and stuff like that. So then another similar thing is PSBT. PSBTs are like the standard partially signed Bitcoin transactions. These are like standardized data structures that are used to transmit partially signed Bitcoin transaction between one device to another. So if you want to understand PSBT, if you are working on a project that works on PSBT, you want to go through this part of the doc. Basically, this describes what PSBT is and how it works in general. So then we have a multisig tutorial. So a multisig, this basically tells you, like, gives you a step-by-step guide on how to do a multisig with Bitcoin Core RPC from your Linux terminal. So this is a very cool tutorial. You might want to try it just to get your hands dirty on how Bitcoin Core works, how to talk with it, how to create wallet, how to create multisig wallet, PSBTs, sign PSBTs, transact PSBTs, broadcast PSBTs, all these kind of things. So there is a nice tutorial over there. And then what else we might want to see? Yeah, files. So Bitcoin core file system. So if you are a node runner or you are a core contributor, doesn't matter. You wanna be very conversant with the file system that Bitcoin Core uses. So Bitcoin Core creates its own data directory, as is shown in the Bitcoin Conf discussion, and along this data directory there are other files that are created, and this document basically describes what are the other files and what kind of information those files contain. So there are blocks, then there are blocks index, the blocks directory. This is basically where all the blocks get stored, right? And then the chain state, then we have a wallet database, and all these different kind of files, and you can go through and see like what are the information that is contained in all these files. So these are the information that you need to be aware about while working with Bitcoin. While doing various peer reviews, you might want to check inside those files and see how the data of these files are changing and all. So that's useful. And what else? So I think we covered most of it. Most of the there are many other docs that you wanna check out at your own time. So we have the Tor documentation. If you wanna run Bitcoin in a Tor mode, so Bitcoin is only connected via Tor, and or like connected via both ClearNet and mainnet, or you wanna expose your Bitcoin D as a Tor hidden service. This document describes how to do that, right? And so we have ZMQ. ZMQ is the zero message QE portal of Bitcoin, where you get notification, so transaction notification, block notification. This is useful for wallets which want to use Bitcoin as their blockchain backend. So they want to use Bitcoin Core to get the blockchain database and sync the wallet in that way. So if you are interested in ZMQ, you might want to take a look on that. So that basically kind of concludes our tour on the documentation folder, and that's all I wanted to show. Setu, you might have any questions or anything, or we can move on.
Yeah, so is there any order in which one should go through the docs, or all the
Not
docs I'm
really.
sure must be connected to each other, like parts of it?
No, no. These
No.
all docs are independent of each other, so you can start from anywhere, and it doesn't matter. So these are all like standalone docs. So no doc is like, it's not a chapter-wise thing. So no doc is connected with one another. Um, I like build doc is probably the first doc you need to go through because you want to build the stuffs. Then I guess developer notes, depending on whether you are going jumping into the development stuffs or not. Yeah, like even I haven't gone through all the docs serially, and it depends on your use cases. It depends on what you want to do next. So you might want to check this stuff. So files, dev docs, productivity MD, and build docs. These are like the basic things that you want to check first.
Got it. Got it. We can move to the next section.
Right. So in the next section, we will basically jump into the code, and the another thing before going into the code, I wanted to show is like Bitcoin configuration. So we talked about the configuration folder, configuration file, and so Bitcoin has the repository has this nice tool in the contrib directory. I don't know if you guys can see it. Let me try to zoom in a bit. Yes, so in the contrib directory, so there is like lot of these are the tool directories. So in the contrib, you will find a lot of Python files, shell script, and tools that a developer needs to use, right? And inside dev tools, you will find something called generate bitcoin conf.sh. So this is a shell script. This is a simple shell script. What it does is, like, when you run it, it will create an annotated bitcoin.conf file for you. So if you don't know what are the configuration to use in your bitcoin.conf file at the start, because you are doing it for the first time, this is a very helpful tool. So all you want to do is, like, just run this thing, contrib devtools generate bitcoin.conf.sh, and it will create a generating example bitcoin.conf file and share examples. So if we go to share examples, where share examples? No, we are in contrib. So share examples bitcoin.conf, and you can see, like, it has created a very nicely documented configuration folder. So this is one configuration, RPC bind address port, and this is the documentation of that configuration, what this configuration does. So very useful to study, and very useful for first time user. If you don't know what are the configuration, you can just copy paste this file, put it into your bitcoin code directory, data directory, and just uncomment each line, and this becomes a valid configuration, right? And you can comment, uncomment, whatever you want. So this is another tool that is very useful. So with that, I think we concludes on the configuration file. Any question?
No, no questions as such. It was pretty self-evident.
Yep, yep. This part of is very simple, and I encourage everybody to go through it and have some time playing around with different configuration and see how your Bitcoin node behaves, right? And the best way to do it is, like, run it with Signet or Testnet, because
Hmm.
in mainnet you're gonna take a long time to sync the database, so before you can do anything meaningful. And in rectest, it's just on your local system, so it doesn't give you, like, a flavor of a running bitcoin node. So Signet and Testnet is where you can play around with this configuration and see, like, what kind of connections you are getting, what kind of connections you are not getting, how to stop a specific connection, how to only activate some particular part of connection, and all these kind of things, right? So
Got it.
with that, let's move on to our next section, which is, like, now we are going to deep down into the C++ code. So this is happening inside the source directory, and inside the source directory we have the entire bitcoin C++ files like they're lying over there, right? So this is the bitcoin engine, if you say. And so we don't want to, like, we'll be covering the full thing because it's literally impossible. There's a lot of code happening, there's a lot of context going on in the background of this code. I just want to give you guys some ideas on the common patterns that are the common part of the code. And I'll basically zoom out because you don't need to read line by line, so I just want to show you the structure of the code in general. So this folder consensus, so this folder contains the consensus related parameters, right? So these are the parameters that are, like, specifies, these are the data pairs, the values, the specific data that determines, like, the bitcoin network. If you change one single parameter in this file, you fork the bitcoin code. You create a bitcoin network that is like different from the existing bitcoin network. So
Oh,
now, like, forking bitcoin code is, like, not that hard. It's just one single line change. And so these are the parameters. There is transaction verify.cpp, where some basic verification is happening on transaction, and validation.a, some basic data structures that are used for validation is defined over here. So and you will see, like, there are, like, lot of folders added over here. So these are modules, so these are, like, logical segmentations of different part of the code. So this consensus folder contains all the consensus related code, not the validation logic. We will look at the validation logic later, but these are basically the data structure, the raw data that you need that to comply with the Bitcoin network in that way. So crypto, all the internal underlying cryptography is basically written over here. So poly 1305, mu hash, sha3, sha256, zip hash, all this kind of things, chacha poly, AES, HMAC, and all the crypto magic that goes inside the Bitcoin protocol is written inside this crypto module. And yeah, if you are a cryptography background, theoretical computer science, and you wanna like go deep into the implementations of the cryptography, there are a lot of scopes to improve. There are a lot of work happen on this domain, but it's quite heavy and quite heavy stuff. So so if you are expert in that domain, you might want find this thing very interesting. Then we have the RPC. So RPC is like if you have a Bitcoin node running, RPC is called remote procedural calls, and with remote procedural calls, you will basically communicate with your Bitcoin node. So you will issue some command, it will answer it back, and it will show you some stuffs. So so the entire RPC thing, the RPC logic is basically written over here. So if you just open, say, raw transaction.cpp, and so if I just collapse this guy, so these are all the RPC functions, right? So if you go to Bitcoin CLI, and to access Bitcoin RPC, you have to use Bitcoin CLI. You start Bitcoin D, then you Bitcoin D runs in the background, then you use Bitcoin CLI / commands to issue certain commands. And you will see this command name inside the Bitcoin CLI help. So combine raw transaction. So what does the command do internally if you want to know? So this is where you look. So this is how the command structure look like. They always follow a same internal structure. And let me just collapse it back. So combined raw transaction, it starts with a helper manual. So that is the help doc that you see if you ask help on combined raw transaction. And this is the logic that goes behind combined raw transaction, right? So this is the C++ code that handles the function, what happens when you call combined raw transaction. And all the RPC calls are like written inside this folder. So these are the mempool related RPC call, mining related, network related, transaction related, and whatnot. Um, so yeah, that's RPC. After RPC, you might wanna. So this is script. So the script interpreter of Bitcoin. So this is the script engine. So Bitcoin has its own scripting language called script, right? So the script of Bitcoin is like what is known as the Bitcoin smart contract, and how the scripts are interpreted, how the script structure is defined, and is basically defined over here. So you can see like these are the opcodes, right? If you have heard about opcodes, this is how where the opcodes and their values are defined, right? And later on, what this opcode does is defined in various match statement. Let me see if I can find it. Um, uh, I think script interpreter.cpp, and inside interpreter.cpp there must be something. Yes, so these are the opcodes. If op this, then do something. If op this, do something. If op check lock time verified, do this. So the entire script language is basically written inside interpreter.cpp. So if you want to know like what op check clock time verify does, it does this. So this is the definition of op check lock time verify. And the good part is like this, the code base is very heavily documented, right? You can see like before like many commands, there are like lots of docs explaining what exactly this thing does and how exactly this thing does its thing. So this is another interesting place to scour into. Not much work actually happens in the script because the script is kind of like set in stone from the very early days. we don't innovate on Bitcoin script. Bitcoin script is a very strictly defined thing, and it has been like this way for a long time. So you will not see a lot of pull request happening on Bitcoin in script part of this world, right? And then these are the tests. So this is one place, if you are already conversant with the C++ code and you want to contribute easily, quickly, these are the place where you might want to look. So these are all the unit tests, right? There are another kind of test called functional test. We'll talk about it later, but these are all the unit tests where each unit function of the code base is being tested here. So you can take a look around all the test cases, and there are many PRs, pull requests you will find where the test cases are being updated, new test cases are being added, and if you can contribute into the test, they are always welcome. So adding something on the test is the easiest way to contribute into Bitcoin Core. So then we have different other kind of testing. For example, we have these test utilities that are used for the testing framework. And then we have fuzz testing. We don't want to go into fuzz testing details, but like the fuzz testing is a different kind of testing where basically you input random data into the function until it breaks, and you find it's called fuzzing. And you find a lot of weird kind of bugs in this kind of test. So we have a lot of like fuzz test happening in Bitcoin Core also. So that's about test. And then what else? We have wallet. So this is where all the wallet related code lies. And if you are a wallet developer and you are already working on your wallet project, you might find this wallet folder very interesting, because this is how Bitcoin Core does its wallet thing. And this is very heavily engineered and very security focused, because a lot of things can go wrong in the wallet code. So you might want to check out like the different parts of the wallet. A lot of work happens over there, so you will find a lot of pull request open on just on the wallet part of the code base. And so that basically covers like the major part of like the modules. There are other modules that you want to look and check, but we'll not go over it right now here. And then you will find all these standalone C++, which are like not part of any module or folder. They are like standalone on their own. And there are a lot of C++ codes going on these folders, which are like outside of any module. And we'll not look at the most of it. Will basically, I just want to basically specify the most two important standalone module, and that is um, net processing.h and validation.h. So where is this validation.h? So in earlier days of Bitcoin Core, there was a main file. Like every C++ project starts with a main.cpp, and there was a main.cpp in Bitcoin, and that we used to do the major part of the Bitcoin protocol validation and networking and validation. Later on, this file was divided into many parts, and different parts of the files are now residing in different modules over here. The major chunk of that code, the networking code, how the Bitcoin core networks with another peer, how the peer negotiation happens, and part of that is heavily consensus focused. And then the validation part of the logic, how the transaction gets validated, how a block get validated, what are the rules that a transaction need to follow. So these part of the code are uh, later on segregated into net processing.cpp. As you will see, this is a very heavily documented file, and this is a very large folder. A lot of functions are going on over here, and many of these parts are basically consensus related. If you change something bad over here, you will fork off the resulting Bitcoin compilation. And then we have the validation.cpp. So validation.cpp is like where the major part of the blockchain validation is happening. This is consensus, right? And again, you will not find a lot of work happening on validation.cpp. validation of CPP is like the mission critical part of the code base. And if anything gets screwed up over here, Bitcoin gets screwed up for everybody. Right, so you will see very experienced developers only touching one or two lines of validation.cpp here and there, and and you should like feel free to like scour through this code base, and it tells you what Bitcoin is. So if you want to understand Bitcoin at the bare bottom, it cannot get more bare than this. So this is what Bitcoin is at the mathematical description of it, and you can just read through many of the functions. One of my favorite function that I want to show is like this one, the get subsidy. So the thing that make Bitcoin Bitcoin is basically this function. I don't know if you guys can see it. I'll zoom it a bit. Uh, so get block subsidy. So what is the block subsidy at each block is defined by these 5 lines of code. And basically this defines the halving, and this defines the inflation schedule of Bitcoin, right? And you can just literally read through it, like subsidy halving interval, this value is 2100,000, 210,000. And then we say the halving epoch. If halving epoch greater than 64, return 0. After 64 halvings, no more Bitcoin, right? This function returns 0. Subsidy starts with 50 Bitcoins, and at each halving, it does one right shift operation. And if you know your basic computer science, a right shift operation in binary is basically halving that number by 2. So if the halving epoch is 3, we right shift 50 by 3 bits, and it goes to 12.5 or 6.25. I don't know. So that's how halving works. So this is like this cute small part of the code that is like defining the heart of the Bitcoin system. And with that, I would like to conclude on the C++ part of the code base. Next, we will look at the testing framework. But before that, any question? Uh,
Is there Bitcoin code is primarily just in C++, not in any other. There's no other language in which it is. The files are available.
Yeah, so Bitcoin code is like so there are like reference implementation of Bitcoin code, and in that reference implementations, there you can have like is a Bitcoin code in like Bitcoin protocol implementation in JavaScript also. There is a Bitcoin protocol implementation in Go, which is used by LND. It's called BTCD. Um, and then we can have like we can have like a Rust based Bitcoin protocol implementation, and there can be like any language you can use to do Bitcoin protocol. It's like this is called the reference protocol implementation, and ideally like what Satoshi released in C++ is the first version of like uh, 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 a programming description, a programming language description of what Bitcoin protocol is. Now you can take the same protocol, the same idea, same concept, and replay it into any other language, and it will work. And there are few other implementations out there like that.
Got it. Got it.
Yeah. And so this is the most majorly used Bitcoin protocol implementation, and the problem of like having a lot of protocol implementation is like you can have sometimes nasty incompatibility bugs. So if you remember a few months ago, there was a bug in LND which was discovered by transmitting a very large multi-sig transaction which worked in Bitcoin core, but it broke BTCD because BTCD had a different parsing logic, and BTCD node stopped syncing after having that transaction. so
Oh,
so that's the problem of like having parallel implementation. You have to be lockstep compatible with the major adopted implementation, and that's where like the implementations tends to get centralized, and tends to have like one major implementation that everybody wants to follow, because if you want to create your own implementation, you have to ensure that it's in consensus with everybody else around you, or else you will fork yourself out. So with that, let's move on to Bitcoin functional testing. And so after C++, if you are intimidated with C++, not to worry, because there is Python. And these Python files are all residing in the functional testing framework. So we saw the unit testing where each individual chunk of C++ file get tested. Here, the Bitcoin code, like the entire Bitcoin system as a whole get tested. So these are called functional tests. And all these functional tests are basically pure Python files. And just like any other Python file, if you have a compiled Bitcoin inside your source directory, you can just play these Python files. And what this Python file will do is like they will create one or multiple Bitcoin node in the background, create a network topography, do communication and operations among them, and do some checking whether the operation is happening as they are supposed to happen or not. So this is called functional testing, or like procedural testing or stuff like that. So and this is the most easiest part of the code base to contribute, because Python is an easy language and it doesn't take a lot to understand how these codes are running. So you can see like it's setting up a clean chain equals to true, number of nodes equals to 1, run test, some directory, initialize data directory, and stuffs like that. And so the best way to start is example.test.py. Inside this folder, you will have this example test.py, and example test.py is basically a documentation on how to write functional tests or how to read through functional tests. The entire concept of functional testing for Bitcoin Core is like demonstrated over here. Very easy to read through. Anybody with basic Python skill can go through this and start playing around. And this is one of the most fun thing to do in Bitcoin Core. You can like play around with a lot of cool things. You can like make three nodes talk to each other and see how the data are flowing in, see what kind of data one node is receiving for another node, do different kind of assertion, and basically like go gaga with Bitcoin in a Python scripting, right? So this is very powerful and one of the best place to learn about Bitcoin. So just to check one, um, I don't know, P2P send transaction control, maybe. So this has number of node 1. I want something with number of node 2. So number of nodes 1, invalid block, number of nodes 1, invalid transaction, number of nodes 1. I can't seem to find a number of node 2. uh, yeah, number of node 3. So you can see like set up nodes. Now connect node 0 with node 1. You can like granularly connect different nodes with different nodes and create your own topography. So you can say like I want node 0 to connected with node 3 and node 1 to be connected with node 2, and then node 0 send something to node 1 and check whether that thing ends up in node 3 or not. And all these kind of like topography thing, you can like script it out on your own using very nice framework in Python. So this is I mostly encourage people to go through the functional testing first before jumping into C++. C++ can feel intimidating, and but Python is like everybody's familiar and favorite language, and there is an entire test suite happening on Bitcoin with Python, and contributions here are always welcome. You will have a very easy time getting your PRs passed through the review process and getting it merged. So um, if you are willing to do your start your Bitcoin Core contribution journey, checking out the Python functional testing framework is the best thing to do. So with that, basically we conclude our session over here. Any more question?
Nothing as such. I think I know from where to get started from. So I think the first place where I will jump on after Bitcoin configuration is Bitcoin functional tests.
Yep.
That seems like the easiest place to jump onto. Yeah.
Yeah, really. And over time, like, it's always gonna feel intimidated at the start, and because Bitcoin, it has a lot of context at the background, the Bitcoin entire machine. So it only gets easier with time. The more you look through PRs, and reviewing PRs is the best way to get comfortable with the code base, with contributing and all this kind of thing. So before, like, even like I suggest, like, before before starting to write code for Bitcoin, you should read code for Bitcoin at the start, and read other people's code, what they are trying to do, how they are approaching that thing, how they are changing it. Test their code, be familiar with all the review process first. Then your contribution process will also get easier. You will know how to change different things when different people ask you to do the XYZ, right? And you will not get intimidated and like bogged down with all the details that are going on. And with that, let's conclude our session over here.
Thank you so much, Raj, for taking us through the second session in Bitcoin Core PR Basics Review.
Yep, yep.
Thank you.
And see you next time.
Yep. See you around.